Hello, class. Today, I will show you how to solve this problem number 4 of the potential energy worksheet that I gave you to work. So this problem is a little bit challenging, but it's not difficult when you understand. Okay, there are a few challenging words here, how to understand things. If you understand that, it will be great. The first, let's read these things. There are 42 kilogram clocks, 20 centimeter thick. I think it's a blocks. It should be clocks. Sorry for the typo. 20 centimeter thick are used to make a retaining wall in a backyard. Okay, so each row of the wall will contain 10 blocks. You may assume that the first rock is placed at the reference level, which is H equal to 0. How much gravitational potential energy is stored in the wall once the block are set in place? So there are 40 blocks, which means that each row contains 10 blocks. That means you have 4 blocks. Let us look at the picture here. I draw for you. So this is the first block. Sorry, this is the first block. You can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, each of the block is 2 kilogram, and each of the block thickness is 2 centimeter. Okay, so which means that say this is your 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Say this is your row 1, and this is 20 centimeter. Let's change it to meter. So this will be 0.2 meter. Okay. All right. So the next one is this. So this is the first row, and the next row is again 10 of them. This is also 0.2 meter. Okay, so each of them have the same thickness. So this is the second row, and since you have 40 blocks, so and let's call this not clocks, blocks. Okay, so the next one is like this. So again, you have up to here. Again, this is 0.2 meter. Okay, so each of them are 0.2 meter thickness. So now we have 30, so we need one more row. So let's call this is your row 2, and this is your row 3. One more, and that's it. So this is again 0.2 meter. Okay. Now, what you have to do that each of them is 2 kilogram. So each row has 10 of them. So the mass of each row, so M row is equal to 2.0 kilogram multiplied by 10. Why I'm multiplied by 10? Because there are 10 blocks in each row, which is equal to 20 kilogram. Okay, 20.0 kilogram. Okay, we'll see at the end of that. All right, so this is one important thing. What else we already know is that G, gravitational acceleration, or the field strength, G is equal to 9.81 meter per second square, or another unit is 9.81 Newton per kilogram, whichever way you want. So, and we have to figure out what is the total potential energy when you laid all these blocks in this way. Now, there is a catch. Where you give your reference, Okay, the reference you have to put this way is that, let me change my color. I see. Change it to green. So here, this is your reference frame. What it said, look at your, read the question. This is h equal to 0. Okay. And then from this one will be h equal to 0.2 meter. This one then will be h equal to 0.4 meter because you add these two height, and this will be h equal to 0.6 meter. Remember, each of them is 0.2 meter thick. Okay, so where I'm starting measuring from the top, when I'm laying down the first row, that is my reference frame. Why I'm doing these things? You can read these things. You may assume that the first rock is placed at the reference level h equal to 0. So that's why I'm taking, when I'm when I'm laying down the first blocks, h is equal to 0. Okay. So I hope you understand these things. Now it's simple to measure the potential energy for each of them, because remember, each row, all these rows are identical. Each row has 10 identical blocks. So each row has the same mass, 20 kilogram. So the first one, say here, let's call this is EG1. Okay. Here, let's call this is EG2. At this level, let's call this is EG2, sorry, 3. And here at this level, you can call this is EG4. We calculate all of them, and then the total will be EG1 plus EG2 plus EG3 plus EG4. Now, what is EG1? So EG1 is equal to, by basic definition of potential, gravitational potential energy is mgh. Okay. Now here m is equal to 20 kilogram. G is equal to 9.81 meter per second square. And for the first one, h is equal to 0 meter. So everything is 0. 0 multiplied by anything is 0. Now, second row, which is golden, EG2 is equal to mgh. Now 20 kilogram, again the mass, the identical mass, right? Times 9.81 meter per second square. The height is, you can see that height is 0.2 meter. So 0.2 meter. And that is, if I use my calculator, this will be 20 times 9.81 times 0.2, which is equal to 39.24 joules. 39.24 joules. Oops, where it is. Keep. Sorry, I will do it. All right, so that's my bad. Anyway, again, let's start. Now we'll do the EG3. EG3 is equal to, again, mgh. M is 20 kilogram. This is for the third one, 20 kilogram. Then 9.81 meter per second square. And we always measure the height from the reference point. So from here to here, the height will be 0.2 plus 0.2, which is 0.4 meter. So 0.4 meter. And that will give you times 2, which is 78.48 joule. Okay. And EG4 is equal to, again, same formula, mgh. M is the same mass times 9.81 meter per second square. And then what you have, your height. Now remember, this height always measure from the reference, which is here. So this is from here to here, which is 0.6 meter. 0.6 meter, and that's give you so 20 times 9.81 times 20 times 9.81 times 0.6, which is 117.72 joules. Okay, so now we can add all of them. We can add all of them. So then E is equal to, EG1 is equal to 0 plus 39.24 joules plus 78.48 joules plus 117.72 joules. If you add them, your total energy is equal to, let's add them, plus 78.48 plus 39.24, which is 235.44 joules. 235.44 joules. And if you take two significant figure, this will become 240 joules. Okay, so that's how you get your answer. See, the answer matches here. All right, I hope you understand this problem, and please try this problem. I will talk more about these things, and we have a quiz tomorrow, so hope this will be benefit to you. Okay, great. Thank you. Bye.